This lesson is find an orthogonal basis for the column space of matrix A. We will use Gram-Smith process to help us find the orthogonal basis for matrix A. So V1 is X1. X1 is the first column. Again, V1 is X1. X1 is the first column. It is already done. There's no calculations. You don't need to find anything. It is already there. So V1 is X1, which is this column right here. So V1 is this column. It is already the answer. No calculation needed. Next, we need to do for V2. V2, here's our formula. X2, which is column 2. X2 times V1. So column 2 times column 1 divided by column 1 multiply column 1. So column 1 multiplied again. And then I have another column 1, which is here. So write it out. Here is column 2 minus column 2 times V1, which is column 1. Okay, so column 2 times column 1. So 3 times -5, -15. 1 times 1, give me this one. -1 times 5 gives me -5. 3 times -7 is this -21. Now the bottom, column 1 times column 1. So 3 times 3 is 9. 1 times 1 is 1. -1 times -1, +1. 3 times 3 is this 9. This V1 right here is column 1 again. Okay, so column 2 minus X2, which is column 2 times column 1, which is for the top. The bottom, column 1 times column 1, which is for the bottom. And then this extra column 1, which is here. Now the rest is just calculations. So bring the column 2 over here. Don't forget this minus, which is here. If you do the calculations for the top and then divide the bottom, which gives me -2. Where does this -2 come from? Add all this up, divide by the bottom, add all the bottom. So top divide bottom, just add the top, divide at the bottom, and it will give me -2. Bring this over here, and the rest is just add and subtract, multiply across. Okay, so negative times negative, so negative times negative gives me positive. So -5. Okay, and here will be +2 times 3 gives me 6. So -5 plus 6 gives me this 1. Next, this gives me positive, okay? And it's a 1 here. So +2 times 1, which gives me +2, plus 1 gives me this 3. Next, this is positive, negative and negative gives me positive, but I have a negative here, so it becomes -2. So 5 subtract 2 gives me this +3. Next, I have -7. So this is +2 times 3 gives me 6. So -7 plus 6 gives me this -1. So this answer right here is our V2. Now repeat that again, the whole process again for V3. Why V3? Because I have 3 columns, okay? So here's a formula. If you notice, it is the same pattern, just add more to it, okay? So column 3 minus column 3 times V1. V1 is our column 1. And this is for bottom, column 1 times column 1, column 1, minus column 3 times V2. V2 is this right here, divided by V2 and V2 again, and then another V2, which is also here. So put all this together. So here we go. This is column 3. Where did I get this from? This is our column 3. So column 3 is right here. Okay, so that's our column 3. Minus column 3 times V1. So where did I get all this number for the top, and where did I get all this number in the bottom? So column 3 times column 1. So 1 times 3 gives me this 3. 1 times 3 gives me this 3. Okay, next, 1 times 1 gives me this positive 1. Negative 2 times negative 1 gives me this positive 2. 8 times 3 gives me this 24. And in the bottom, column 1 times column 1. So 3 times 3 is 9, which is here. And then 1 times 1, which is this 1. And then negative 1 times negative 1, which is this positive 1. And then 3 times 3 gives me this 9. And then V1 is the column 1. Okay. Next, this right here, where did I get this from? So column 3 times V2. So here's column 3 and here's V2. So 1 times this 1 gives me this 1. 1 times 3 gives me this 3. Negative 2 times this 3 gives me negative 6. And then 8 times negative 1, which gives me this negative 8. Okay, and then where did I get this right here? This part in the bottom right here is V2 times V2. So V2 is right here. 1 times 1, 1. 3 times 3, 9. 3 times 3, 9. Negative 1 times negative 1, positive 1. Okay, and then now we just put all this together so that I have the answer for V2. So bring down the column 3. Okay, if you add the top and add the bottom, divide it, I would get negative 3 over 2. V1 is the column 1. Don't forget this minus right here. Add the top, add the bottom, divide, gives me negative 1 over 2. V2 is this right here, so bring it down. Okay, and then the rest is just add, subtract, and multiply all the way across. So here we go. So here's negative 3 over 2 times 3. Okay, so I have 1, which I have right here, 1. Minus 3 over 2 times 3 gives me this negative 9 over 2. Negative and negative gives me positive times 1 is positive 1 over 2, which I have here. And just go across 1. Here's the 1. Negative 3 over 2 times 1 is just this negative 3 over 2. This gives me positive times 3, so 3 over 2. Next, negative 2, so here's negative 2, and negative 3 over 2 times this negative 1, which gives me this positive 3 over 2. This right here become positive times this 3, which gives me this 3 over 2. Okay, and then the last one, 8, so here's 8, and then negative 3 over 2 times 3 gives me this negative 9 over 2. This right here is my positive. Negative and negative gives me positive, so times another negative, which gives me this negative 1 over 2. Okay, and then the rest is just add and subtract this part right here, so that will become our V2. So, and if you add them all up, so all this right here, 1 minus 9 over 2 plus 1 over 2, what gives me this negative 3. 1 minus 3 over 2 plus 3 over 2, what gives me this 1. Okay, and then negative 2 times 3 over 2. Negative 2 plus 3 over 2 plus 3 over 2 gives me this 1. And then finally, 8 subtract 9 over 2, subtract 1 over 2 will give me this positive 3. Okay, so now this is the orthogonal base for V1, V2, and then V3. So this is the orthogonal basis that we are looking for, okay, for this matrix A. Again, using Gram-Smith process to find the orthogonal basis for this matrix A. Okay, so one more time. V1, it's already done, so no calculation. So we just column 1. V2, here's the calculation to get V2. V3, same process, just a little bit more procedure. So follow the pattern, and that will give me our V3. So here's our V3 right here. Okay, so this is our V1, this is our V2, and this right here is our V3. So in general, our orthogonal base is this, which is for the column space of matrix A. Okay, so again, this is the solution of the orthogonal basis to this matrix using Gram-Smith process.